Today we are going to talk about probably the most misunderstood element in solar battery systems. It's this thing here that's called an ATS. It's the automatic transfer switch. So I'm going to explain what it does and how we can use it for different purposes in the solar system. A good battery system installation must have an ATS. If it doesn't have an ATS, actually when the solar system for some reason has a failure, you will not have power in the UPS panel. So you will lose all the essential loads, which is, that's not the way an installation should be. Should always have an ATS, so that if there's a failure in the solar, which can happen because of something going on the grid, something bad on the grid, and then it must shut down or it has a fault because of something. Solar systems are not perfect. It can go into fault sometimes. And if somebody tells you that it will not, they're basically lying to you, because solar system is just like any technology. Yes, they are very, very good and stable, but they can fail. And when that happens, we need to have mechanisms that is so that we can use the system and use the electrical when the solar is being fixed or there's a failure on the grid, wait for that to be okay again. Of course, in a normal situation, if the grid has a power failure, power cut, then the solar system will give power to only the UPS. That's why I have two panels, because when you are off-grid, when there's a power failure, only this panel is being used. So that's the normal functionality. But this thing here does not switch over when there's a power cut. Then the switching happens inside here. So that is one of the big misunderstandings about the ATS. People think that it switches over when you have a power cut. That's actually not what it's doing. When there's a power cut, I'll show you. We have two outputs of electricity from this inverter, and all hybrid inverters. You have the backup and you have the grid. So when there is a power cut, the inverter switches and stops output here and only has output on the backup side. So the backup side is not connected to the grid and gives then power to the UPS panel. So that is why a hybrid inverter has two outputs. One is being used when the grid is up, one is being used when the grid is down, the backup side. So that's why inside here you actually have 6 inverters. You have 3 for on-grid and 3 for the backup when you have a power cut that's not connected to the grid. So that means that there's no reason the ATS does not work in a situation where you have a power cut. It's only the inverter that goes from the output on the grid side to output on the backup side. That's all that happens. And I can show that. I'm going to pull this down. The ATS will not switch. The switching will happen in here. And we will see that now. So we cut the power. Now there's no power from the outside. The inverter went into fault, but it will go out of fault. It just happened here. So now we're on backup. And this one did not switch, because when this switches it has a big sound, and this one goes over like this, from normal to the backup or the reserve. So now it's on normal, even though we are off-grid. We are off-grid because the main is down. The inverter is doing the switching. It's switching from the grid side to the backup side, giving power to the UPS, and now we are not connected to the grid at all. This is the way that it should be. So the ATS right now is not working, and that's the main point to remember, that in a normal functioning power cut, the ATS is not switching. So now we can go back. So now we're back on grid, and we have then everything is connected to the grid. So now the inverter will soon go back and output on the grid side to both this and this. That is the normal functionality.